Okay, number 18. In a certain chemical reaction, the number of grams N of a substance produced T hours be, after the reaction begins is given by N of T is equal to 16T minus 4T squared, where T is between 0 and 2. First of all, let me finish it up and then I will explain something. At what rate in grams per hour is the substance being produced 30 minutes after the reaction begins? So with calculus, calculus is the study of rates of change. And a derivative that we've talked about before is a rate of change. Previous to calculus, we were mainly working with functions. We were working with quantities. For example, the number of grams of a substance can be modeled by N of T is equal to 16T minus 4T squared. So if you plug in T there, what it will tell you is at any time T between 0 and 2, it will tell you how much of a substance is being produced. How much of the substance is produced up to that point there. But that is not calculus yet. Calculus is telling us how fast or how slow the substance is being produced at a particular point in time. Now, it may be a constant growth or a constant rate of growth, or it may be a constant rate of decay. But more often than not, the rate at which something changes is changing over time. Just like when you drive in your car, you're not always going at the same miles per hour, right? So miles per hour is a good example of a derivative. It's not miles, it's not a quantity, but it's a rate of change of miles per hour. So, and your rate of change, your velocity or the speed that you're traveling at, it varies throughout the course of your journey there. Well, the same thing is going to happen in many cases. As a reaction, as this chemical reaction takes place, perhaps at the beginning, uh, fewer grams of the substance is produced, but near the end of the chemical reaction, more and more is produced until time runs out, until the 2 minutes is up. So what we need to find here for this particular problem is we need to find the rate at which the substance is the rate at which the production of the substance is changing. And that's what we're being asked for. At what rate in grams per hour is the substance being produced? Is the quantity of the substance changing? So we're being asked to find a rate, and a rate is a derivative. So that means that we have to find a derivative of N of T. Now for this particular test, the amount of calculus that you need to know is very basic. You must be able to find derivatives of polynomials, and fortunately that's the easiest thing to find a derivative of. For example, in this case the derivative, now you should know that the derivative of a sum or a difference is just the sum or difference of each of the derivatives of each of the terms there. So we need to find the derivative of 16t, and what you do is this is what's called the power rule. So 16t is really 16t to the first power. And you're going to bring that exponent down and multiply it by the 16. And then you're going to reduce that 1 by 1. And so that becomes 0. Well, so what you end up with is 1 times 16 times t to the 0. And t to the 0 is 1. So that's 1 times 16, which is 1, which is 16. Which is 16. The derivative of 16t is just 16. The derivative of 4t squared is 8t. And so the derivative of n, or n prime of t, is 16 minus 8t. And we want to find, that's the rate of change. We want to find that rate at which the substance is being produced 30 minutes after the reaction begins. However, our variable is in hours, so we need to convert the 30 minutes to a half. So we plug in 0.5 for t, and we get 16 minus 8 times a half, which is 16 minus 4, which is 12. All right, so you should be able to find derivatives of polynomials and to be able to evaluate them at specific points there. All right, so that's the main thing in this particular example, and you should be good at that. Fortunately, that's the easiest part of calculus.